This video is going to discuss concepts of calculus. It is going to help grade 12 learners prepare for calculus, and it will also help grade 12 learners to learn calculus. So if you are new to this channel, please hit the subscribe button so that you get notified when content like this is uploaded. We are going to start first by learning the concepts of limit. Let's say, for example, we have to evaluate the following limit. If we have the limit x is approaching 3, and then the expression that is within the limit is x squared minus 9, all divided by x minus 3. So the idea of the limit is that where we see x, we have to substitute the value of 3. But now, if we try to do that directly, we are going to notice something. Let's try now to substitute the value of x as 3. At the top, we have now x squared, so that means we're going to say now this is 3 squared, and this is minus 9. And at the bottom, when we substitute x, we're going to get 3 minus 3. But now, if you try to put this in your calculator, you're going to get undefined. The reason why you get undefined is because now at the denominator, you're going to get 0. So every time when you get the denominator being 0, you're going to get an undefined. So that means we can't directly substitute x as 3. But now what we have to do, we have to actually simplify our expression to see if ever there is a way whereby we can substitute the value of x as 3 and then we get any valid value. So now before we substitute the x as 3, we're going to keep on writing the limit as x is approaching 3. But how to simplify this expression? If you want to simplify a fraction expression, what you do, you factorize when necessary. Looking at the expression at the top, we can actually factorize because we have difference of 2 squares. But at the denominator, there's nothing we can do. So we are going to try and factorize what we have at the top. So you're going to open 2 brackets because this is the difference of 2 squares. And then we say now the square root of x is going to be x, the square root of 9, that's going to be 3. And then we just repeat those. And then we write the plus and the minus. And then the denominator we have x minus 3. So after we factorize that, we will see that the denominator is going to cancel with one factor at the top. So this means the expression simplifies to now become x plus 3. So if we want to substitute the value of x as 3, we are not going to get undefined. So therefore, we are going to substitute the value of x as 3. But when you substitute, you have to stop writing the limit, and then you write equals to, and then you substitute the value of x as 3. So this will be 3 plus 3. So therefore, the limit is going to be 6. Let's look at the second example whereby we have the limit a approaching negative 2, a squared minus 3a minus 10, all divided by a plus 2. The very same thing will happen if we will try to substitute the value of a as negative 2. So if we try that, we will see that at the denominator, we are going to get negative 2 plus 2. So now negative 2 plus 2 is going to give us 0. So every time when the denominator becomes 0, we get an undefined. It doesn't matter what is it at the top. So this will therefore mean we can't actually directly substitute the limit. What we have to do is that we have to simplify the expression first. So remember, the way that we simplify an expression, we have to actually factorize where it's necessary. Looking at the top, we have a trinomial. We can factorize a trinomial, but at the bottom, we can't factorize because it's a plus 2. There's nothing we can do. So we're going to factorize at the top. So remember, when you factorize a trinomial, you open 2 brackets, and then you say, now, how can you write a squared? You're going to say a multiplied by a. And then you're going to look for the factors of the last term, which is 10. So the factors of 10 is 1 and 10 and 2 and 5. So now these factors of 10, when you subtract them, because the last sign is negative, they must give you the middle term, which is 3. So those two factors that when we subtract them, they're going to give us 3 is going to be 5 and 2. So we're going to put them randomly to say now the factors is 2 and 5. But now, if this last sign is negative, that means the factors will have different signs. And the bigger factor will take the sign of the middle term. So the 5 is the bigger one, so it has to be negative, and then the other one will be positive since we have the last sign as negative. So after we have done that, we can clearly see now a plus 2 is going to cancel with one of the factor. And then the limit is going to simplify to be a minus 5. So we can clearly substitute the limit as negative 2. So if we substitute it, it's going to be negative 2 minus 5. Negative 2 minus 5 is going to give us negative 7. Let's say, for example, now we are given the following limit. The limit as x is approaching 4, x squared minus 16. How can we evaluate this limit? So remember now, the idea of the limit is just to substitute the value of x as 4. So if we can try to do that, we are not going to get undefined since we don't have any fractions. So that means we can directly substitute the value of x as 4. So let's try to do that. We're going to say now this limit is going to simplify to be the following. Remember, when you substitute, you stop writing the limit. So this is going to be 4 squared minus 16. So now 4 squared is going to be 16 minus 16, and therefore the limit will evaluate to be 0. So if you get the answer as 0, therefore 0 is a valid answer, then you are done. You don't only want to get 0 at the denominator, but now if you get the answer as 0, that is valid enough. Let us look at one last example of a limit. Let's say we have limit x is approaching negative 3. And then we have x squared plus 7x plus 12, all divided by x squared minus x minus 12. So now, is it possible for us to substitute the value of x as negative 3 directly? So we can try to do that. Let's substitute now the value of x as negative 3, especially at the denominator, to check now if at the denominator we get 0. Therefore, that will therefore mean we can't actually use that. So if we substitute x as negative 3, we're going to get negative 3 squared minus negative 3 minus 12. So now the numerator is going to simplify to be what? Negative 3 squared, that's going to be 9. And then negative by negative, that's going to be plus 3. And then this is minus 12. So we can clearly see now 9 plus 3 is going to be 12. And then 12 minus 12, that is going to give us 0. So this therefore means we can't actually substitute the value of x as negative 3 directly. We have to actually simplify the expression and then see if we substitute, we're going to get any valid answer. So now if we look at the expression we have, we can actually factorize at the top and we can factorize at the bottom. So we are going to factorize at the top and at the bottom. So at the top we have a trinomial, so we're going to open two brackets. And then we say, how can we write x squared? We can write x squared by saying x multiplied by x. And you're going to look for the factors of the 12, and when we add them, they give us 7. So now the factors of the 12 is 1 and 12, and then it is 2 and 6, and then it is 3 and 4. So clearly, when we add 3 and 4, we are going to get 7. So that means this is going to be the suitable factors. So we're going to say now we have 3 and 4. But now remember, the last sign is positive, therefore the factors will have same signs. And they're going to take the sign of the middle term. So they're going to both be positive. At the denominator, we still have a trinomial. So if we want to factorize a trinomial, we open two brackets. We ask ourselves, how can we write the first term, which is x squared? We can write x squared by saying x multiplied by x. And then we also look at for the factors of 12 that when we subtract them, they give us a 1. So now remember now the factors of 12 is what? Is 1 and 12. And then it is 2 and 6. And it is 3 and 4. So still, these factors of 3 and 4, when you subtract them, because the sign says minus, they're going to give us 1. So that means these are the suitable factors. So we're going to choose them to say now this is 3 and this is 4. But now if you look at the denominator, the sign is negative. That means the factors are going to have different signs. But now the bigger factor will take the sign of the middle term. So the bigger factor is 4, so it's going to be negative, and this is going to be positive. So after we have done that, we are going to notice that the x plus 3 is going to cancel out with the x plus 3. And therefore our expression is going to simplify and become x plus 4 all divided by x minus 4. So now when we get to this point, if we substitute x as negative 3, the numerator is not going to be equal to 0. So therefore we can substitute our limit. So we're going to say now when you substitute, you stop writing the limit, and this is going to be negative 3 plus 4 all divided by negative 3 minus 4. So now negative 3 plus 4 is going to give us 1. And then negative 3 minus 4 is going to give us negative 7. So therefore the limit is going to be negative 1 over 7. So now that we are done with the concept of limits, we are going to move on to try and understand another concept. This concept that we are going to try and understand is actually finding the first derivative using the first principle. So remember, if you want to find the first derivative using the first principle, you are going to use the following equation. The first derivative of x is equal the limit as h is approaching 0, f at x plus h minus f at x all divided by h. So now this is the equation that you need to know for you to be able to do the first principle, finding the first derivative using the first principle. So let's say, for example, we are given the following expression to find the first derivative using the first principle. F at x equal 3x squared minus 2. So the first principle says that we must first find f at x plus h. So what does that mean? It means now on our equation, we are going to substitute the value of x as x plus h. So let's try to do that. We can say now f of x plus h is going to be equals to, so therefore where you see x, you're going to put what? X plus h. So this is going to be 3, and then when you see x, you're going to say this is x plus h, but now you have to square everything since that was squared. And then we now have minus 2. So this is what is implied by f at x plus h. And then now the f at x is just going to be the original equation. So if we try now to plug in everything on the original equation, let's see now what we will get. We're going to say now the f at x as the limit of h approaching 0. The f at x plus h is now given as what? As 3 into x plus h squared minus 2. And then we have to minus the f at x. Remember now the f at x is the original function, which is 3x squared minus 2. So be careful now when you minus the f at x, because if you have a polynomial, that means you must put the bracket since the minus will multiply with every term inside. So remember now all this must be divided by h from the equation. So now that we have everything substituted, we now have to simplify. So we have to simplify because if we wanted to directly substitute the value of h as 0, that means the denominator is going to be 0, and then that's going to be undefined. So we have to simplify first to see now if ever we can simplify this whole expression so that when we substitute h as 0, we don't get undefined. So now, how do we do that? We are going to continue to say now the first derivative as the limit h approaching 0. We simplify at the top. So now this thing here is squared. So now when something is squared, it means is that they multiply by itself. So but now how can we factorize such a thing? So we factorize it by saying now we square the first term. So that's going to be x squared. And then we say first term multiplied by the second term. So x multiplied by h, that is xh. And then you multiply that by 2. So that's going to be what? Positive 2xh. And then lastly, you square the last term, which is h, and that is going to be h squared. So now you still have the negative 2, but now when you multiply with the negative on this 2 brackets, you're going to get what? You're going to get now this is negative 3x squared, and that's going to be positive 2. It is very much important that you multiply those two factors or those two terms with the negative outside. And therefore at the denominator we still have h. So if we continue now to simplify at the top, We are going to multiply everything else by the 3, and then we'll have to cancel out things that cancels and see what happens. So if we say 3 multiplied by x squared, that's going to be 3x squared. 3 multiplied by 2xh, that should give us 6xh. 3 multiplied by h squared, that should give us 3h squared. And you have minus 2 minus 3x squared plus 2 all divided by h. You will notice something special is going to happen. Everything that does not have h at the top, it is going to cancel out. For example, you're going to say now 3x squared is going to cancel out with the negative 3x squared. And then now the negative 2 will cancel out with the positive 2. And then at the top, you are going to be left with things that only have what? That only have h in them. So if you simplify this, we're going to say now the first derivative as the limit is approaching 0. Now the expression is simplified as x, as 6xh plus 3h squared all divided by h. We cannot still substitute the value of h since the denominator is going to be 0. So this will therefore mean we have to factorize at the top, since we can factorize by taking out a common factor. So the first derivative is going to be equals to the limit as h is approaching 0. If you take out h as a common factor, we are going to have 6x plus 3h. So all this must be divided by h. So now if we do that, we're going to see now the h and the h will cancel out. And then the whole expression will now simplify to be something that we can actually substitute h as 0 on it. So this is going to be 6x plus 3h. So now if we substitute the value of h as 0, we are going to get a valid answer. So therefore we have to stop writing the limit when we substitute. So the first derivative of f at x is going to be what? It's going to be 6x, and then where we see h, we're going to put 0, and therefore that will just simplify to be 6x. So let us use now the first derivative to solve the following problem. Let's say we have f at x equal 7 over x. Can we find now the first derivative using the first principle? Of course, we are going to use the equation that says the first derivative is the limit h approaching 0, and then we have now f at x plus h minus f at x all divided by h. Remember now, this is the equation of the first principle. So now in the equation, we can now substitute everything that we need to do. So I'm not going to write now the first derivative. I'll just continue with the equal sign and say now as the limit is approaching 0, and then I'm going to put in here the f at x plus h. So remember now, f at x plus h, this simply says that where we see x, we substitute x plus 8. So therefore that is going to be what? 7 over x plus h. And then now the original function, which is f at x, it was 7 over x. So we're going to substitute the original function, which is going to be 7 over x. And then all this is divided by h. We can substitute the limit as h approaches 0, because now we are going to get undefined. So but now if you look at the top here, what is it that we can do? Because now we can factorize. There's something that we can do, which is now saying that we have to add the fractions. You see at the top we have fractions. We have to add the fractions. So now how do we add the fractions? We're going to now write the limit h is approaching 0. So when you add the fractions, what you do, you just simply multiply the denominator. You say this denominator multiply by that denominator, and you write it down as your denominator. So you're going to have now x plus h multiplying with x. But now after you do that, you have to cross multiply. Now you will say now this 7 will multiply with the denominator there, and then this x plus h will multiply with the 7 at the top. But now we have to keep the minus in between those two things. So you're going to say now 7 multiplied by x, that's going to be 7x. And then you're going to say what? We put the sign which is negative, and then we say now 7 multiplied by this part here, which is x plus h. So now that is how we actually add the two fractions at the top. But now remember, you still have the denominator as h. So we just added the fractions now, but now we have to now simplify what is at the top on the fraction. So how do we simplify? We must remove the brackets. So remember now, if you remove the bracket, you will multiply everything by that -7. So this will therefore mean now we have 7x, and then -7 multiplied by x, that's going to be -7x. -7 by h, that's going to be -7h. And then at the denominator, we now have what? We have x into x plus h. So at the denominator, you don't necessarily want to factorize, but if you could factorize, if you could simplify, I mean, you can simplify. But in this case, please just keep it as it is. You don't have to simplify at the bottom. But now remember now, at the denominator, we still have now dividing by h. So now, if we look at the top now, we're going to say now the 7 will cancel out with the 7. So the 7x minus the 7x is going to give us 0. So therefore, the fraction at the top will just simplify to be -7h all divided by x into x plus h. Remember, all this is divided by h. So now, if we write this like this, we can clearly see now what is happening. So we can change the division to multiplication. But remember now, you have to always write the limit. If you stop writing the limit, you are going to lose your marks. So you will have now limit h as h is approaching 0. So now you will write now your limit h approaching 0, and therefore you're going to change the division to multiplication sign. So this will therefore mean we have now -7h all divided by x into x plus h. But now when you change this to multiplication, that means now the top will come to bottom and the bottom will come to top. So this is going to be 1 over h. So once we do that, we can clearly see now this h is going to cancel out with that h. And therefore, the expression will be simplified to be now, as h is approaching 0, we have -7 all divided by x into x plus h. Remember now, at the bottom, you can simplify. It is really up to you. So I just like keeping it like that, just in case we had something that will cancel out with the top. Okay, so now if we look at this, we can clearly see now if we substitute the value of h as 0, we are not going to get undefined. So this will therefore mean we have to substitute the limit. So when we substitute the limit, we now have to write to say now the first derivative, it is now becoming, you don't have to write the limit because you substitute it. So you're going to have -7 all divided by x into x plus 0. So now x plus 0 is just x. But now if you now simplify this, that's going to be -7. And then x multiplied by 7, x multiplied by x, that's going to be x squared. And that will be the first derivative using the first principle. So now, let's say, for example, we're having now a cubic. So let's say now we have now f at x being equals to 4x cubed. So how would you now use the first principle to actually solve this first derivative? You will have to write down your equation to say now this is going to be the f of x, the first derivative of f of x, when the limit h is approaching 0, f at x plus h minus f at x all divided by h. So remember, when you see x, you're going to place it with x plus h. So you have to keep on writing the limit as h is approaching 0. But now the f of x plus h is going to be 4 into x plus h cubed. And it is going to be minus f at x all divided by h. So but now you can't write just f at x because you know what f at x is. Remember, f at x is what? Is minus 4x cubed. So with this being said, now we have to simplify because we can't directly substitute the limit as 0 since we are going to get an undefined. So therefore, we have to say now the limit as h is approaching 0. Remember now, if this is cubed, that means here you open 3 brackets. So we're going to now have 4 into x plus h into x plus h squared. Then you have now minus 4x cubed all divided by h. So the reason why I'm just making this to be x squared, because I can easily simplify this without going an extra mile. So now we have to simplify at the top. We're going to say now the limit h is approaching 0. Then we have now 4 into x plus h. Or we can actually multiply this out. We're going to say now we have 4 multiplied by x. That's going to be 4x. And that's going to be plus 4h. And then that is going to be multiplied with this thing here. So now this thing we're gonna be able to simplify it by saying now this is going to be x squared. So that's going to be what? X squared. And then you say now x multiplied by h, that's going to be xh. And then you multiply that by 2, that's going to be 2xh. And then you square now the h, that's going to be plus h squared. So you still have the minus 4x cubed, all divided by h. So after you have done this, now you have to multiply out everything on this bracket with everything on the other side of the bracket. So you will write now your limit as your h is approaching 0, and then now you multiply out. So it's going to be 4x multiplied by x squared, that's going to be 4x cubed. 4x multiplied by 2xh, that's going to be positive 8x squared h. Then 4x multiplied by h squared, that's going to be positive 4xh squared. And then now we are done with this 4x, you're going to use now the 4h. So 4h multiplied by h squared, that's going to be 4x squared h. And then 4x multiplied by 4h multiplied by 2xh, that's going to be what? Plus 8xh squared. And then 4h multiplied by h squared, that's going to be plus 4h cubed. And then you still have minus 4x cubed, all divided by h. So remember, everything that does not have h will cancel out. Looking at this 4x cubed and the 4x cubed will cancel out because they are minusing out each other. So now everything at the top, it has h as what? As a factor. So now at the top, let's first look at if we have now like terms. So we can clearly see now we have x squared h and x squared h there. So that means now we can add those like terms. So that means now if we add them, we are going to get what? We're going to get that this is going to be 4 plus 8, which is going to be 12x squared h. And then we have now this as a factor, and that is a factor. I mean, as a like term. So 4 plus 8 is still going to give us 12xh squared. And therefore, we are left with what? With plus 4h cubed. So in this case, when the expression is reduced, we can easily now take out the common factor without confusing ourselves. So we're going to keep on writing the limit as h is approaching 0. And then at the top now, the common factor will be h. And then we have 12x squared plus 12xh plus 4h squared, if you take out h as a common factor at the top. So once you have done that, you will clearly see now this h and h will cancel out. So now when you substitute now your h as 0, you're not going to get undefined because now the denominator is no longer there. So this will therefore mean now we can stop writing now the limit to say now this is going to be the first derivative. And then you substitute where you see h as 0. So we're going to have now 12x squared plus 12x. And then where we see h, we put 0 plus 4 into 0 squared. So now all these things that have 0 there will just be 0. Therefore, the first derivative of the 4x cubed is going to be 12x squared. So that is how we use the first derivative to actually find the first. That's how we use the first principle to find the first derivative. So now we are going to also learn the simplest way to actually solve the first derivative. So now how do you solve the first derivative? So for you to solve the first derivative, you are going to use a rule. Let's say, for example, you have now x to the power of n. Let me just say f at x equal x to the power of n. So the rule that you use to find the first derivative, it is as follows. You will say now the first derivative of f at x is going to be equals to. So now you're going to say your exponent will multiply with the coefficient. So in this case, our coefficient is just 1. So if you say n multiplied by 1, that's going to be n. and then you write down whatever that you have. But now your exponent should also be minus with 1. So you're going to say now this is n minus 1. So this will represent the first derivative in a short way. So what you do, you just take out the exponent, you multiply it by the coefficient, and then you subtract the exponent by 1. So let us try to apply that in different expressions. Let's say, for example, you have the following equation. F at x equals to 3x cubed plus 7x squared minus 4x plus 2. So let's now find the first derivative by just using a short method. So we'll say now the first derivative of x is equals to, remember, the exponent will multiply with the coefficient. So this is 3 multiplied by 3. 3 multiplied by 3 is going to give us 9. And then now we're going to say now the exponent will have to minus with 1. So it's going to be 3 minus 1, and that's going to be squared. That's going to be 2. 3 minus 1 is 2. And then we do the very same thing for everything. We're going to say now this is going to be 2 multiplied by 7, and that's going to give us 14. And then if we say 2 minus 1, that's going to be 1. So if it's 1, we don't have to write anything. So now if you look at this one, now we have the exponent as 1. So 1 multiplied by negative 4, that is going to be give us negative 4. But now if we minus 1 on the exponent, we're going to get now exponent of 0. And then if you have exponent of 0, that means any number raised to the power of 0, that is 1. So that means now we don't have to write any x because it is going to be equals to 1. So now if you have a constant, when you do now the first derivative of a constant is just going to be 0. It will fade away. So this is now how you find the first derivative using the simple method. So now let us keep on practicing how to find this. Let's say, for example, now we have the following: g of x being equals to 2 over x squared minus square root of x. So how would we actually find the first derivative of this? Before we can now try to apply the law that we have used to say now the exponent will multiply with the coefficient and then we minus the exponent with 1, we have to first simplify. For example, if x is on the denominator, we have to write it at the top. And then if x is inside a square root, we have to take it out. So we're going to first start to simplify everything that has what I've just mentioned. So you don't first find the first derivative. You write now your g of x, but now you simplify this. So remember now, if x is your denominator, you're going to take it up. But now when you take it up, remember the exponent changes the sign. So this is going to be minus 2. This is going to be 2 into x to the power of minus 2. And then now if you take something out of the square root, remember now the square root means squared and then the exponent is 1. So that means now the square root will divide the exponent of whatever you have inside. So in this case, this is going to be x to the power of 1 over 2. So now that you have done that, then you can now apply what? Your first derivative. So remember now your first derivative, you're going to say what? This thing here multiplied by that, the exponent multiplied by the coefficient. So negative 2 multiplied by 2, that's going to give us what? That's going to give us negative 4. Then you're going to have now x to the power of what? Negative 2 minus 1. And then now if you look at this one, you're going to have now the exponent as half. So you're going to say now half multiplied by negative 1, that's going to be negative 1 over 2. And then you have x, remember the exponent is 1 over 2, but you have to minus 1. So I'm writing in the minus 1 here so that you see now where the exponent will reduce to be. So now if you simplify this, that's going to be g of x, the first derivative of g of x, and then you're going to get now negative 4 x to the power of negative 3, because minus 2 minus 1 is negative 3. And then you have now 1 over 2 x to the power of what? If you say 1 over 2 minus 1, that is going to give us negative 1 over 2. And this will be the first derivative. So now if the question says you must leave your answers in a positive exponent, that is when you have to simplify this further. For example, you will say now your g of x is going to be equals to what? You're going to say minus 4. And then this thing here, you can take it down to the numerator by changing the exponent to be positive. So this is going to be all divided by x cubed. And then now if you look at this, what we have now, you can actually take it down to the denominator. So this means you have now, you have minus 1 over 2 x to the power of positive 1 over 2. And then now you can also write this positive 1 over 2 as a square root. But now it depends on what the question wants. But in this case, you are done by just finding the first derivative up until here. unless the question states otherwise. Please just look at what the question says. So now let us continue now to use this simple derivative to find the derivative of the following. Let's say, for example, we have now f at x being equals to x plus 4 over x squared. So now in this case, how would we find the first derivative? So to find the first derivative, that means now we have to actually separate these terms, because it seems like we have two terms and we added them because the numerator were the same. So before we find the first derivative, we will write down the f at x is equals to, we can simplify this and write this as what? As x over x squared plus 4 over x squared. So this is the very same thing, because now it comes from this. Remember now, if you were having the same denominator, you just add the top part. So that comes from that. We just separate them so that we see what is happening. So now after we do this, we can clearly see now something's going to happen, because now this will cancel with one of the x's there. And therefore that's going to be 1 over x. But now we don't want to write it as 1 over x because we want x to be at the top. So that means now we have to also simplify this further to say now this is going to be x to the power of -1 since it was at the bottom. And then also we have to bring this x squared to the top. So that's going to be x to the power of -2. So then if we have a linear equation like this, then we can now start to apply the first derivative. So the first derivative of f at x is going to be equals to what? Remember now you say now exponent multiplied by the coefficient, that's going to be -1. And therefore you're going to have x to the power of what? -1 minus 1, which is going to be -2. And then here you're going to have -2 multiplied by +4, that's going to be -8. And then you have now x to the power of what? -2 minus 1, that's going to be -3. So but now remember, it is not okay to write a coefficient of 1 there. You have to just remove that. So therefore your answer is just as follows. Negative x to the power of -2 minus 8x to the power of -3. So that is how we can solve that. So now, with that being said, we can now move on to another type of problems. So let's say, for example, now I tell you that if you want a gradient of any line, you can just find the first derivative. So what do I mean? So if you have any function, for example, a linear function, if you have mx plus c. So this gradient of this function is the same thing as the first derivative of that function. Okay, let me just make an example. Let's say we have now f at x equal 2x plus 3. So if the question asks you find the gradient of this function, we will say now, okay, the gradient of this function is just going to be the first derivative of the function. So but now if you apply the first derivative, remember now this exponent is 1 there, you're going to say 1 multiplied by 2, and that's going to give you 2. Because now that is x, that will disappear because it's going to be 1 minus 1, which will make the x to be the power of 0, and then that's going to be 1. So now if you look at the constant is just going to be 0. So now the first derivative is equal to 2. Therefore, the gradient of this function is 2. And we can clearly see that the gradient of the function there, it is 2. So now when you talk about a gradient of any function, we talk about the first derivative. So this concept, we're going to use it to find the gradient of any particular line or to find the gradient at a particular point. Let's say, for example, now, the question says that we must find the gradient at a specific point. Let's say we have now f at x is equal 7x squared minus 4x plus 8. And then they give us now a coordinate. They say now at the point -1 is to 19. So what you have to do now, you have to find the gradient at this point. So what do we know? We know that the gradient is f at x. Is the first derivative of f at x. So we are going to find the gradient. So now that means the gradient is going to be the first derivative. So how do we find the first derivative? We say this multiplied by that. That's going to give us 14. And then you say 2 minus 1. That's going to be 1. Then if you look at this, the exponent is 1. So it's going to be 1 multiplied by -4. That's going to be -4. And then if it was just x, it's just going to be -4. And then if it is a constant, we don't write anything. So this is the first derivative of what? Of this function here. So this is the gradient of the function. But now the question said we must find the gradient at a specific point. The gradient where x is -1. So now how can we find the gradient where x is -1? We will say now, okay, the gradient where x is -1, this is equals to, so that means where we see x, we're going to put -1, and then we're going to get the gradient at that specific point. So the gradient at the point where we have x as -1 is going to be what? 14 minus multiplied by -1, that's going to be -14 minus 4, that will give us -28. So this will be the gradient of this function at this point. So you first find the derivative. After finding the derivative, you substitute the x value, and then you get the gradient at that particular point. Let's say, for example, we have now the following. To say now, can you find the gradient at this point? We have y equals to 2 over x plus 3. And then the point is 8 is to 3, 1 over 4. So remember now what we have to do. We have to find the derivative. So the derivative of y is just going to be y prime. But now you can't do that because now your x is on the denominator. So you have to first simplify this. Just move the x from the denominator, put it at the top before you can apply your derivative. So that means now you still have y equals to 2. But now if you move this to the top, that's going to be to the x to the power of -1. And then you have plus 3. So now you can apply what? Your derivative. You will say now your y prime is going to be what? The -1 multiplied by the +2, that's going to be -2. And then -1 minus 1, that's going to be x to the power of -2. And then this one here is a constant. That means it's going to be disappearing. So now this is the gradient of this particular function. But now, what is the gradient at this point? So now the gradient at this point, that is where we substitute what? The value of x as 8. So the gradient at that specific point. So we're going to say now the gradient at that point is going to be equals to, where we see x, we're going to put now 8. And then we're going to simplify that. So now, if we simplify this, that's going to be what? That's going to be -2. This is just going to be 8 squared. Because if you take it down, the exponent will change the sign. So now, what is 8 squared? I think 8 squared is is 64. So that means you're going to have 2 over 64. And then now, let me just quickly confirm that through the calculator. That will give us now our first derivative as -1 over 32. So that's the gradient at that specific point. So now, let's say, for example, again, they say that we must find the gradient of y equals to 7x minus 8 at the point whereby we have 7 is to 41. So what is the gradient at this point here? So now remember, now if you look at this, now this is a straight line. So the gradient of the straight line is same throughout. So we will therefore now say the gradient is the first derivative, but now there's no way you're going to substitute x as 7. So therefore your first derivative is just going to be 7, and that will be the gradient of your line. So remember now, if you have to find the gradient at a specific point, what you do is that you first find the derivative, and then you substitute the x value, you get the gradient at that specific point. So now, other questions will come like this. They will give you now the gradient of the function, and they will want you now to find the coordinates of that point. Let's say, for example, they give you the following function. F at x equals to x squared minus 7x plus 12. And then they tell you now the gradient is equal 1. Okay, they can give you the gradient as the first derivative, or they can give you the gradient as m equals to 1. They can give you in weight to say the gradient is equals to 1. So now, how do we find the coordinate where the gradient is actually equal to 1? So the first thing that we'll do, we will have to find now the first derivative of the equation. After finding the first derivative of the equation, we already know that the gradient is 1. So we'll substitute now that first derivative as equal 1, because this is given, the gradient is equals to 1, and the gradient is the first derivative. So if we were to find the first derivative of this, we're going to say now the first derivative is equals to, remember, it's going to be 2 multiplied by the 1, that is going to be 2, and that's going to be 2 minus 1, that's going to be 1. So that will just simplify to be 2x. And then if you look at this one here, the exponent is 1, so that's going to be just negative 7. And then a constant will just disappear. So this is now our first derivative. So now we have to find the coordinates when the gradient is equals to 1. So now what is the gradient? The gradient is f, the first derivative. So that means now the first derivative is 1, and therefore we can actually find the x coordinate at that specific point. So if we transpose the 7 to the other side, that's going to be 1 plus 7, that's going to be 8, and then we have 2x. So if we divide both sides by 2, we'll therefore see that the value of x at the gradient is actually equals to 4, because now 8 over 2 is 4. So now that we have the x value, we can substitute it on the original equation to get now the corresponding y value. So therefore we'll say now on the original equation, we are looking for now f at 4 is equals to, so when we see x, we just put 4. And that's going to be 4 like that. And then that is what we have. So now if you want to find now the value of y, where x is 4, we'll say now 4 squared, that is going to be 16. And then 7 multiplied by 4, and that is going to be negative 42. And then that is going to be plus 12. So now 16 plus 12, that is going to be 28. So we have now, we're going to have now 28 minus 42. So if we say 28 minus 42, we are going to get that we have now the answer is 14. Negative 14. Okay, so remember now you can just punch this on your calculator as it is so that you don't make mistake. I don't even know if I made mistake, but I do understand that you understand the logic behind this, and that is what is very much important. Let's say that we are given f at x equal square root x minus 3, and then we are told that the gradient is equal 1 over 2. So the question also says find the coordinates at this point. So remember now we are told the gradient is 1 over 2, but now what is the gradient? Remember the gradient is the first derivative. So this will therefore mean we have to find the first derivative of the function. So but now if you look at this, we have now a square root. So we have to first simplify this function to say now this is going to be x to the power of 1 over 2 minus 3. And then after we simplify it, then we can find the first derivative. So remember now the first derivative, what we simply do, we say now the exponent multiplied by the coefficient, that's going to be 1 over 2. And then we're going to say 1 over 2 minus 1, that is going to give us a minus 1 over 2. And then now, if you look at the constant will just disappear. So after we have done that, we have to now find the coordinates. So we're going to now define the coordinates, but now remember now, the gradient is given as 1 over 2. So we'll therefore substitute the gradient as 1 over 2, and then we have now 1 over 2, x to the power of negative 1 over 2. So in this case, we can divide both sides by 1 over 2. So if we divide both sides by 1 over 2, we're going to get 1 is equal x to the power of negative 1 over 2. So now how can we find the value of x in this case? So we can find the value of x by actually multiplying the exponent with its reciprocal. So we're going to multiply this with negative 2. So if we also multiply the exponent with negative 2 on that side, we also have to multiply it with negative 2 on this side. So now 1 to the power of negative 2 is just going to be 1. And then now this will just cancel out, and then we're just going to have now x being equals to 1. So therefore the value of x is equal to 1. So but remember, after you find the value of x, you're going to substitute it on the original function and then determine the corresponding y value so that you have the actual coordinates. So you're going to say now f at 1 is equal to the square root of 1 minus 3. So you just substitute the value of x as 1 there. You find the corresponding y value. So the f of x at f at 1 is equal to the square root of 1 is just 1 and minus 3, that is going to give us negative 2. So therefore the coordinate is 1 is to negative 2. So let us do now one more example. Let's say for example we are given that f at x is equal 4 over x plus 3, And then we are told that the gradient is -1. And the question also states that the value of x, it must be bigger than 0. So now how do we find the coordinates? So we are given the gradient is -1. So that means we must find the first derivative, since the first derivative is the gradient. So we are going to first simplify this so that x can come at the top. So we're going to have now f at x is equal 4 into x to the power of -1 when it comes to the top. And then we have now the plus 3. So now when we find the first derivative, what we're going to have is that we're going to say now this -1 will multiply with the 4. That's going to be -4. And then if you say -1 minus 1, that is going to be -2. But now remember the constant, it fades away. So now that we have this, we know that the gradient should be -1 as it is given on the question. So we're going to substitute the gradient as -1, and then we're going to try to solve now the coordinate, which is now -4 to the power of, multiply by x to the power of -2. So in this case, we can just simplify at that side to say now this is the same thing as -4 over x squared, if we just write it as a positive exponent. And then from here, we can just cross multiply. So if we cross multiply, we're going to say now x squared will multiply with the -1. That's going to be -x squared. 1 will multiply with the -4. That's going to be what? And that is going to be -4. So now if we divide both sides by -1, the value of x squared is equals to 4. So now remember, now when you apply the square root, you will always get plus or minus. So the value of x is either -2 or the value of x is +2. But now the question strictly said that the value of x must be greater than 0. So therefore the solution is x is equals to 2. So you have to write now this is not a solution at this moment. So now to find the coordinates, you will also have to find the value of y. So that means now on your function, you will substitute the value of x as 2. So you will say now the f at 2 is equals to 4 over 2 plus 3. So now the f at 2 is going to be equals to what? 4 over 2, that is 2. 2 plus 3, that is going to be 5. So the coordinates will be 2 is to 5. So that will be the coordinate of that point. So now let us look at another type of questions that you can get in calculus. For example, they will say now, find the value of a and b for each of the following. Let's say, for example, they tell you now you have f at x being ax squared plus bx minus 6. And they tell you now at this specific point, 2 is to -8. The gradient is equal to -5. So they give you now specific point, and then they also give you now the value of the gradient. And they say now at this point, that is where we have now the gradient is -5. So now this means a lot of things. Remember now we want to solve the value of a and the value of b. So how can we do that? Firstly, we can use now the coordinates that we have. We have now the x and the y coordinate. We can substitute them directly on the equation and make that to be equation number 1. So how do we do that? Remember now we have y as -8. That means now you're going to say f at x is equals to -8. And therefore, when you see x, you're going to put 2. So this is going to be a, it's going to be 2 squared plus b, where you see x, you put 2, and that's going to be -6. So the first equation is going to be -8 equals to 2 squared is going to be 4a, and then 2 multiplied by b, that's going to be 2b, and we still have -6. So to simplify this, we can actually move the 6 to the other side. That is going to be what? That is going to be -8 plus 6, which is the same thing as -2. And then we have 4a plus 2b. So we can say now this is our equation number 1. We used this point. So now what else can we use? We can use now this point, this thing that they gave us. They told us now at this specific point, the gradient is -5. So now what is the gradient? The gradient is the first derivative. But now is the first derivative for what value of x? Where the value of x is equals to 2, the first derivative is -5. So that is what they told us. Okay, so now how do we actually find or simplify this thing? So we're going to say now on the function, we're going to find the first derivative. So the first derivative of the function is going to be equals to what? So remember now the first derivative, you say this multiplied by that, that's going to be 2a. And then you say now 2 minus 1, that is going to be 1. And then here, remember now, if you just have x, that's going to be a b. And then if you have a constant, that will just disappear. So this is going to be the first derivative. So now they told us the first derivative where x is equal to 2, the derivative is minus 5. So therefore we have to say now, okay, the first derivative is minus 5 when the value of x is equal to 2. And this will be our equation number 2. So now this thing is going to be the same thing as minus 5 equals to 2 multiplied by 2. That's going to be 4a plus b. And this will be equation number 2. So now we have equation 1 and equation number 2. So we can actually solve this simultaneously by using elimination method. Some person will use a substitution. It depends on what you want to use. So let's say, for example, we keep these equations close to each other. I'm going to say now the equation 1 is minus 2 equals to 4a plus 2b. So now I can clearly see that if I try to actually subtract this equation, the minus 4a and the minus 4a will cancel out, and then I will be left with one variable. But now you need to be careful because now this is going to be negative 5 minus 2. So that is the same thing as negative 5 plus 2. So negative 5 plus 2, that's going to be negative 3. And then this is equals to, that will cancel to 0. But now you'll say now b minus negative 2b, which is going to be negative b. And if you divide both sides by negative 1, therefore the value of b is just going to be equals to positive 3. So now that you have the value of b, you can substitute it now on any of the equation, either equation 1, either equation 2, to get the value of a. So let's use now the equation number 2. We're going to say now we have minus 2 equals to 4a plus 2. But now when we see b, we are going to put what? 3. And therefore this is going to simplify to be minus 2 equals to 4a. 2 multiplied by 3, that is going to give us 6. Then if you move this to the other side, that's going to be minus 2 minus 6 equals to 4a. And therefore minus 2 minus 6, that's going to be minus 8 equals to 4a. And then you can divide both sides by 4. Therefore, the value of a is equal to minus 2. So we have now the value of a and the value of b. So that is how we can find those coordinates, those variables a and b. So let's say, for example, we have another expression. And then on this expression, we are told that the function is f at x. Then we have x cubed plus 5x squared minus ax plus b. So we still have to find the value of a and the value of b. Consider that the gradient at this point, remember now the gradient at this point, which is minus 4 is to 50, it is equal to negative 1. We are given now the gradient at this point is negative 1. So now what do we know? We are going to do the very same thing. So we're going to say now we can use now this first coordinate to actually determine the first equation. So the coordinate lies on the function, so we can substitute those coordinates on the function and get the first equation. So this will therefore mean where we see y, we're going to put 50. So f at x is y. So that's going to be 50. Where we see x, we're going to put now negative 4. So this is going to be negative 4 all cubed. And then we have plus 5 and negative 4 all squared minus a. And x, you put now negative 4. And this is going to be plus b. Okay, so now we have now 50, and then now if you simplify this, 4 squared is going to be 16. 16 times 4, and maybe that thing might give me a problem. Let me just put this on a calculator. 4 times 4 times 4, that is 64. So, but if it is cubed, it's going to be negative 64. And then now we have now negative 4 squared, which is going to be 16. 16 times 5, that is going to give us 80. And then negative 4 by negative a, that is going to be positive 4a, and then we have plus b. So now in this case, we can add the like terms. So if you say negative 64 plus 80, the value that we get is 16. So now if you transpose the 16 to the other side, this is going to be 50 minus 16. And then that is going to be equals to 4a plus b. So now if you say 50 minus 16, that's the same thing as 34 equal 4a plus b. So this is going to be your equation 1. So now how do we get the equation number 2? Remember, they gave us the gradient at this specific point. So that means the gradient is the first derivative. So now we are going to find the first derivative of the function. So the first derivative of the function is equals to, remember, you say now the exponent, which is 3 multiplied by the coefficient, which is 1, that's going to be 3. And then you say exponent minus 1. So 3 minus 1, that's going to be 2. And then you do the very same thing here. 2 by 5, that is going to give us 10. And then now 2 minus 1 is just 1. So now remember, now if you just have x, that means it's just going to be negative a. And then now b here in this case is going to be what? It's going to be a constant. It does not have x. So that means b will fade away. So now this is our derivative. So now we are told that the derivative is our gradient, which is equal to negative 1. So we're going to say the gradient is negative 1, but now at what point? At the point where x is equal to minus 4. So that means now we're going to say this is negative 1, and then we're going to substitute the value of x as minus 4, and then we see what we get. That's going to be 10 into minus 4 and minus a. So from this expression here, we can actually get the value of a directly, because now we're going to have minus 1, and therefore negative 4 squared is going to be 16. 16 times 3 is going to be 48. And then now if you say 10 multiplied by negative 4, that is going to give us negative 40 and minus 8. So now negative 48 minus 40, that's going to be 8. And then if you put it to the other side, that's going to be negative 1 minus 8. And that's going to be negative a. So now negative 1 minus, that's going to be negative 9. Then we have negative a. If you divide both sides by negative 1, therefore the value of a should give you positive 9. So now if we have the value of a as 9, we can now find the value of b by substituting on this first equation we have found. So we're going to say now we have now that 4 equals to 4, where we see a, we just put 9, and that's going to be plus b. So now if we say 4 multiplied by 9, that's going to be 36. So that's going to be 34 minus 36, which is equals to b. So therefore the value of b will be what? 34 minus 36, that should give us negative 2. So now we have the value of a as 9 and the value of b as negative 2. Thank you very much, guys. I hope this video will help you with practicing and understanding this concept. Remember, you can pause, try the question first by yourself, and also try to make the video to go slower if I'm moving at a fast pace. Thank you. Until we meet again.